Welcome to my video lecture on resolving power of telescope. Resolving power of telescope is a topic which comes under Unit 3 wave optics. And this is Dr. Preeta George, Associate Professor, Department of Physics, Dr. MGR Educational and Research Institute. What can you view from this slide? Yes, one room is dark and the other one is bright. What makes you to distinguish it as dark and bright? It is the resolving power of human eye. Then, what is resolving power? It is the capacity of the human eye to view two images clearly which are placed close to each other. Resolving power of the human eye can be, or the resolving power can be also called as resolution. Resolution is defined as the smallest distance between two particles which allows them to distinguish from one another. Here you can see different optical instruments. Photographic camera, microscope, telescope, magnifying lens, goggles are some of the optical instruments, and each optical instrument has a distinct resolving power. Even human eye has a distinct resolving power. Now, we will see the telescope. Who invented telescope? Yes, telescope was invented by Galileo Galilei. And then what is telescope? It is an optical instrument used to view distant objects much nearer to your eyes. Let us see the parts of the telescope. The major parts of the telescope are the objective lens, focus, and the eyepiece. What is the role of the objective lens? The incoming light will be gathered or collected at the objective lens and it bends it into the focus. In the focus, the incoming light is bent into a bright point and the eyepiece brings the bright image from the focus and it magnifies to the size of your eye's pupil. Definition of resolving power. Resolving power of an instrument is defined as its capacity to see two objects separately which are placed very near to each other. And each optical instrument has a particular resolving power. Then what is resolving power of a telescope? It is defined as the reciprocal of the smallest angle subtended at the objective by the two distant object points which can be just seen as separate ones through the telescope. Theory of the resolving power of telescope. Let D, look at the ray diagram. Let D be the diameter of the telescope with objective AB. O and O prime are the two distant point objects subtended at an angle d theta. The image of the object is a diffraction pattern. P1 and P2 are the position of the central maxima of two images. P1 and P2 are the position of the central maxima of two images. Then, according to Rayleigh, two objects O and O prime will be just resolved when the central maxima of the diffraction pattern of one coincides with the first minimum of the diffraction pattern of the other. Consider triangle ABC. From triangle ABC, what is BC? BC is equal to AB dot sine theta d theta. AB dot sine theta d theta can be written as AB dot d theta. AB can be replaced by d dot d theta. The sine theta d theta will become as d theta for the smaller angles. And if d dot d theta is equal to lambda, then d theta is equal to lambda by d. This condition holds good for the rectangular apertures. And for the circular apertures, Airy, a scientist, have multiplied this equation with a correction factor 1.22. So d theta will become as 1.22 lambda by d. The reciprocal of d theta measures the resolving power of a telescope. Resolving power is equal to 1 by d theta, which is equal to d by 1.22 lambda. Then, Rayleigh's criterion for resolution. Lord Rayleigh was a British physicist who proposed this criterion, which can be termed as Rayleigh's criterion for resolution. Rayleigh's criterion for resolution is obtained as theta is equal to 1.22 lambda by d. What is theta? Theta is the minimum angular separation, lambda is the received wavelength, and d is the diameter of the telescope. These are the images which is obtained at the screen. These diffracted rays interfere and produce diffraction patterns. These are the diffraction patterns. This shows that a interference of rays takes place and the corresponding pattern is obtained on the screen with the central maxima followed by the central bright spot. Thank you.